Hello. So I'm going to be going through part 4 and 5 of my question. So in part 4 we're trying to find the number of zeros within a period. I think now's probably a good time to mention, sorry, if you've not seen my solutions to part I, and part 3, then that's in my previous video, but I'm going to be doing part 4 and 5 today. Yeah, anyway, so we're trying to find the number of zeros within a period of length k. So the 5 has a period of 20, so and we can see there's 4, so that's what I mean. So for 20 there's 4, and so the thing to recognize is that the zeros have to be evenly spaced. This is because given some zero, there will be something like this round it, so you have the two A's follow, because if there's a number there, the one before and the one after have to be equal, and then the two after and the two before have to be negative of each other, and then we get 2A, and we sort of get this pattern again where we get that every even one which is even distance away is the negative of each other, and everyone that's odd away, so odd away from the zeros, this is the third one after the zero, is the same. Okay, and for instance, the reason that the zeros have to be evenly spaced is for if any one of these was a zero, the negative of 0 is still 0, so for all each one that's so any n away from a 0, the other side also has to have a 0 on that side, and then for that 0 there also has to be a 0 2k away and 3k and so on, because you just keep going on the zeros and keep going backwards and forwards, essentially just adding a 0k along. Okay, so now I've explained why the zeros are evenly spaced. What if there's an even number of numbers between each zero, or there's two cases. If there's an even number of numbers between the two zeros, in the case of 5 there is, but there could also be an odd number, and we have to show the two different cases. So for even, there's going to be 1 dot dot dot, and then at some point it will get to the 0, and it will be minus a 0 a, and then at the next 0, because this is even away, we're assuming that the length of this box has an even number of numbers. This one will be the negative of -1 here, and the positive of the 1 there, because this one will be even away from that 0, so it's the negative of each other, and these ones will be odd away from this 0, so they'll be the same as each other. And then we can keep doing this for the next one. The next 0 will be the negative. The ones after this 0 will be the negatives of a, and then we have minus a, and then after that we then repeat, because the negative of this one will be -1 1 0 1 1. So if there's even spacing, there has to be 4 zeros, but just a special case. So if a is equal to 1, there isn't a contradiction for all numbers, because except 1, which is 2, because if these two a's are 1 1, then there's been a repetition, which means that these two have to be the same as these two a's here, because it's repeated already, which means it will repeat after the same amount again, but which would ordinarily be a contradiction, because if a is 1, then how can 1 be equivalent to -1? But obviously when we're working with mod 2, and then 1 is equal to -1, so 2 is a special case of that one, and in that case it also shows that 2 is the only one which has an odd numbered period, because it's the only one. All other ones which have even spacing are going to have 4 zeros, and otherwise for each one which has odd spacing, as in odd numbers between the zeros, the 0 will add on, so odd plus 1 makes it even, and then so however many zeros there are, it doesn't matter, because they'll still be even. So 2 is the only one which has an odd period, and we know this to be 3 because it's 1 1 0 1 1 0, so that's 3, as we've already known. But just to show there's no other ones like that. Okay, so with odd period it's the reverse. So instead of it being minus 1, 1 there. Sorry, I meant to write a there. A, sorry. Dot dot dot. We get minus 1, 1 because it's now odd instead of even. So the one which these two will be the same and those two will be the negatives of each other. And so that's already repeated. So there will only be 2 zeros. Except in the case where a is 1, in which case there'll be 1 0. And there's no contradictions for any of them. A can just be 1. But that will have an even period, but it will be divisible by 2, and yeah, not divisible by 4, which is what we're going to show now, that if and only if the period is divisible by 4, then there's going to be a 0 in the middle. So 1 1, and when we hit the next 0, after the period's ended, it will be like that. So this is the end of the period and this is the start. Then working backwards, again we get this 1 minus 1, because this 0 is essentially equivalent to this theoretical 0 here. So the even ones are going to be negative to each other, and the odd ones are going to be the same as each other. So for instance, that's going to be 2, that's going to be 2, and then that's going to be minus 3, that's going to be 3, and then all the way up to, since this is evenly, because if this was by 4, 4n minus 2 divided by 2 is 2n minus 1. So this group here, between, they'll meet, they'll both have gone to an odd number before they reach this middle point here, which we'll call x, which means that they will be the same. And since they are the same, this one must be a 0 in the middle, unless both a and a is 0. But if a and a if both of those two are 0, then the zeros wouldn't be evenly spaced, which is already a contradiction. So the middle one must be a 0. And if for instance this wasn't divisible by 4, there can't be a 0 in the middle, because this group would be even instead of odd. And we've already shown that if they're even and not divisible by 2, there'll be 4, and there'll be at least 4 of them. So if this is the even group here, there would have to be an extra group there and an extra group there, which is already a contradiction. So that doesn't matter, that's impossible if it's not. But also if you just write, that would be a minus a. The only one could be possibly if it's half. Yeah, it doesn't matter, because we've already established there's a contradiction, because if it is even spacing, then it has to be 4 unless it's 2, but 2's not going to be divisible by 2 anyway, because it's odd. So yeah. Anyway, so now there's going to be an extra. If this group here is, we've already established, is odd, but if this group number subtracted by 1 is even, is divisible by 4 again, so this group here, we will get this, we're working with this group here, so 0, then a, and then the end of the group ends minus 1, 1, 0. And this group, we're saying, if this group is even length here, no, because it's odd, but I mean if it is subtracting 1, because we already know it has to be odd because of the thing there. When I subtract 1 and divide by 2, so if these two groups here are even, not the whole group, sorry, I should have made that clear, even, then this one will be a 0, and I'll show why. Because on this other side we have the 0, 1, 1, and then a minus a, and then we have this same point here, and since it's on either side of the zeros, it's actually going to be an odd spacing away, because it will be even up to this point, because we said this is even length. So these two will be equivalent because they're odd spacing. So, and we can call this C and D if we want, it doesn't really matter. But and then this is A, C and AD, because this is going to be the same sequence, because it's just times by a each time, because we started off by adding a's. So we can call this this term C plus D, and we've said that C plus D is equivalent to A C plus D, and that would only be the case if A's equivalent to 1, which is a contradiction, because then it would have already repeated, because if these a is a 1, then it's already a repetition anyway, so that's a contradiction. And so the only other scenario is that c plus d is equivalent to 0, and therefore we've shown that that's equivalent to 0. But again, if this is odd spacing, this can't be odd spacing and have a 0, so that's the other case, because we've shown that if there's odd spacing, there can only be 2 zeros, and there would be 4 zeros in this thing, so that's a contradiction. So it's if and only if this group, once you've subtracted 2 divided by 2, if that is then, when I subtract another 1 and divide by 2, it's even, then there's a 0, but that's if and only if, so both ways. So now we've established that we can go back to what I've written over here, which is the answer to my thing, that if is just divisible by 4, so because I've written 2 different terms for the 2 different divisible by 4. So both of these numbers are divisible by 4, but one is divisible by 4, and then these two, when I subtract 2, the 8n just represents, because 8n minus 2 divided by 2 is 4n minus 1. Then when I subtract another 1, we get 4n minus 2, and then n minus 2n minus 1. So that's just representing when this group here would be odd, and this one is representing when it would be even, because it would be 8n plus 4, so minus 2, so 8n plus 2 divided by 2, so 4n plus 1, then subtract 1, so 4n, and then divided by 2, so 2n. So that's just representing when this box is even and when this box is odd. So when this box is odd, so or when the period is of 8n, we get that it has 2 zeros, so the one in the middle and obviously the one at the end, which all of them have. 8n plus 4 has 4, and all others, because it's if and only, it has to be divisible by 4 to have one in the middle, and since they're evenly spaced, they can't have, you can't, for all cases, if it is, there must be one in the middle, as we've shown here, because if there's even spacing, there's one in the middle, and if there's odd spacing, there's still one in the middle. But there's only one in the middle if there's 4, so all other ones which aren't divisible by 4 must only have 1 zero. So all else has 1, so that's our answer. So if it's in the form 8n, and I think I labeled it, so yeah, instead of n it should be k. So if k is in the form, if k is in form 8n, then there's 2. If it's in the form 8n plus 4, then 4, and all else will have 1 0. So now this makes 5 fairly easy, because we've already established this rule here, and I can tell you, you can just work out the only way this case would happen in the 3 would be if all zeros, for all zeros in the n to the a plus 1 is also a 0, and we can just by going to the first 0 in all of these, that is not the case, and therefore all of these numbers, you can do this yourself, but all these numbers must be part of this one. So that is just 2 has, let me just do them quickly. 2 has period 3, so that's 3 times 2 to the 4 is a period of 2 to the 5, and then the period of 27 is, I believe 3 has period 8, which I showed in the other one, but I will do it again. So it starts 1 1 0. Oh, no, that's bad. 1 1 2 0 2 2 1 0 1. So that's 1 2 3 4 5 6 7 8. So 8 times 3 squared, because we're just doing that twice. And then the 5 has period 20, that's one up there, so that's 20 times 5 squared. And then 11, let's do 11 quickly. 1 1 2 3 5 8 2 10 1 0 1 1. So 1 2 3 4 5 6 7 8 9 10. So that has 10. So that's 10 times 11, or 110. And then we just want to find the lowest common multiple of all of them. So we will write this 20 as 2 to the 2 times 5, and that 8 is 2 to the 3, just to make it more clear, to easier find the thing. So the maximum with 5 is 3, so it's the lowest common multiple of all of the 2 to 5 times 3 to 3 times 5 cubed times 11 squared, which is when joining them together, as I showed it, which I covered in, if you don't remember, it was covered in II, why that is the case. So watch my previous video if you don't understand why it is the lowest common multiple. So that would be 5 cubed, and then the max for that one is 2 to the 4, and then obviously there's the 11, so you have to times by 11, and then the maximum 3 is 3 squared. So that is the lowest common multiple of the whole thing. And let me just put that into my calculator real quick. 5 to 3 times 2 to the 4 times 11 times 3 squared is, that's all equal to 198,000. And so that's the length of the period of 13,068,000. And then, so if I do a million divided by 198,000, which is, so that's 10 to the 6. 6 divided by 198,000, there is 5 point, is equal to, so 10 to the 6 over 198,000 is equal to 5.051. That's rounded, but, and then since 1980 is that it's divisible by 4, I think 19800 is divisible by 4, so that's it definitely has 1 0 in the middle. But then if I subtract 2 and divide 2 again, it is odd, so it is in the form 8n and not in the form 8n plus 4, and not in that one, so it must have 2 zeros in each period and one of those in the middle. So it does not reach, since this is not, this term is not, it's not greater than 5.5, it must be 10 because there's 2 in each period, and the 11th one will occur when it's 5.5. So the answer to part 5 is 10. Alright, goodbye.